Did you get a good lunch? Me too. I was downright, I would say, satisfied by that. It was pretty good. Anyway, thanks for being here. My name is Tim Berglund, and I guess that's only sort of subtly hinted at on the slide. I just realized that my name is not there. My Twitter handle is there, but my name's Tim. Hi. This is my first time in Singapore. I am delighted to be here. A little bit of a struggle actually getting here from the United States because there's kind of bad weather in the western part of the US right now, or at least there has been, and that made things a struggle, but it's good to be here. I work for a company called Confluent. We have, well, you probably saw me on the stage earlier accepting the sponsorship thing, so we have a booth over there, and we make an event streaming platform based on Apache Kafka. Kafka is what I want to talk about today. Oh, what do I do there? I guess that matters. I run the developer relations team at Confluent. So if you go to a Kafka meetup, there's a good chance we had something to do with it. If you see somebody from Confluent like me speaking at a conference, there's a good chance my team had something to do with it. If you read documentation or you watch a tutorial video or anything like that, that's all stuff that we do. We want to make it easy and fun for you to adopt Kafka and some of the things that Confluent makes as well. So anyway, glad you're here. Some quick questions about you. Who feels relatively new to Kafka? Good, okay. Who feels pretty comfortable and experienced with Kafka? All right, so a lot of people in between. Anybody using Kafka in production right now? I always mean to do that next to the one who's new to Kafka, because sometimes they're the same hands, you know. Hey, look, it happens. We do our best. Anyway, great. So what this talk is all about is giving you an idea of the whole breadth of the Kafka ecosystem. We've only got about 45 minutes to do it in, and there's a lot to talk about. And the reason I wrote this talk is because I find people who still think of Kafka as a queue, it's a scalable queue. You know, it's a really big one. It's this really big pipe, and that's kind of early Kafka thinking. Maybe 5, 6, 7 years ago. That's what Kafka was when it was new. That's really all it did. But there is so much more now that has grown up around it. People started to use that big pipe to build systems, and that created the need for various components to live around the pipe. And so really Kafka is this fairly interesting ecosystem for doing stream processing. And I just want to give you a sense of all of that. You have various, kind of a distribution of experience and familiarity with Kafka. Some of you are new, some of you are not. I'm going to assume that all of you, though, write computer programs. And maybe that's not everybody. It was kind of funny. This morning, there was the question, who's written code in the last week? Most of us stood up. I was able to stand up. I will confess, there are weeks where I would not have been able to stand up. I was glad this week I could. But anyway, I'm assuming that you write programs. And here's a question, what do your programs do, right? Well, most of the time we take requests from a web form or posts to an endpoint, and we put something in a database, or we get something out and we serialize it as JSON and we send it back to the browser. Kind of depressing, actually, if you think about it that way. It's all sort of the same. But I'm going to assume that our programs process events. Now, that's a very Kafka-centric way of looking at the world, but even if you've never touched Kafka or a message queue, things happen to your software. Your software receives input of some kind, and then it does computation and it produces a result, right? So we write programs that process events. Events like this lonely little guy right here. It's just a thing that happens. There's some kind of structure in there. We'll get to that. I don't know. The problem is there are a lot of these things that happen. Really what Kafka's mission is to help organize those events and give you a way of thinking about them. How does it do that organizing? Well, this is what we're going to do. We're going to start with an event, and we're going to end up with some fairly advanced stream processing at, I'll say, 2:45, or 2:15. Sorry, panic there. About 2:15, we'll end up with some fairly advanced stream processing, starting with this event. Now, Kafka gives you a little bit of structure. It says an event, we're just going to say an event is a key-value pair. What's the key? What's the value? Doesn't matter. Kafka is untyped internally. It doesn't care. They're bytes. It's a key and it's a value. Now, typing matters a lot outside of Kafka to us kind of at the API level, but as far as Kafka is saying, an event is a key value pair. What is that key value pair? Don't know, don't care. It could be all kinds of things. It could be a sensor reading from some device. It could be a record of an interaction with a customer, right? Like a customer clicked on the website, or a customer called, or a customer bought something. Those are all events. It could be some change in state in a business process, like an event, or pardon me, an invoice became past due. That's an event. Or an order shipped. That's an event. Could be, in general, this is actually the stuff that gets me really pumped. The output of any microservice is an event. Now, where you put that event, how you store it, how you represent it, up to you, but it's possible, and even I would suggest probably a good idea, to produce that to a Kafka topic. The output of a microservice is an event. All these things are events. Now, where are these events going to go? If you've ever used a messaging system, or you've read more than like 300 words about Kafka, you probably know that they go into things called topics. This is not a new term. Every enterprise messaging system in the world, that's a different kind of thing than Kafka, mind you. The whole point of this talk is to make an argument that Kafka is not just a messaging system, but it shares that language. Events go into topics. So these events happen, and they just get loaded into this basically list of things. Here's an important point. Sometimes I forget to say this, but it matters a lot. What do we know about events? So think about, sometimes it's good to think like events, just that the events that you produce. Like you speak words. You say a sentence. That's an event. You spoke words. Maybe you were upset at the time that you spoke them, and you said something later on that you wished you hadn't said. You can't undo that, right? That's immutable. Sometimes tragically immutable events are. So we know these events here are also immutable. Once they get produced to a topic, we might choose to forget them after some period of time, but they are immutable. And that's a very important simplifying assumption system-wide. Events are immutable, just like they are in real life. Can't change the past, can't change an event once it's produced to a topic. So a topic is fundamentally not a queue, but a log. And we'll get to that difference in a little bit. I don't ever want to hear you say a Kafka queue. If you say it, that's okay. If you say it in your team meetings, if you write it on whiteboards, just don't do it in front of me if you can avoid it. They're not really queues, they're logs, and we'll get to why in a little bit. So inside these topics, there's an ordering guarantee. There should be a little asterisk on strict. We'll get to that in a minute, but there is an ordering guarantee here. It's very fast to write and read to these things. Kafka doesn't do much in terms of storage. It does store. These are durable. Okay, topics are log files on disk, and they're durable. They're replicated. The data's there, but it really just appends those events to the end of a log file, or does a very simple lookup by offset by the number of the message in the log. So reads and writes are constant time, but also not real fancy. If you think about that, if all you had was a log, and that was the entire representation of your data everywhere, that would be a terrible life. Because now to find all of the TL Berglund orders, you have to look through all of them, and that would be just, you don't want to live that way. You know, that's why we have databases with indexes and things like that. But as just a kind of a fundamental base layer place to put events to start with, that's what topics are. Now, I just said some things that are sort of, I guess they could be classified as dramatic irony. Kafka is fundamentally a log. It's a distributed log. That's what it does. But all of these things build up on top of it that give it functionality that is very much unlike a log and more like this database construction toolkit. And I think you'll kind of get that idea as we go forward. Anyway, partitioning. Why do we partition? Well, we got these logs, but a log by itself can get too big. There can be too much I/O, right? I can be producing too many messages or consuming too many messages for one computer to keep up. Also, just putting this on one node would sort of be a single point of failure. So we're going to develop the ability to split these topics into partitions. All right, a partition is just a slice of a topic. So now, when I have a key value pair and I want to write it, I have to decide where to write it to, right? These partitions are theoretically going to be stored on different nodes, at least some of the time. And so a client trying to write this thing might have a whole different computer to connect to, a whole different socket over the network. So one of these key value pairs, one of these events comes in, and what we do is we run the key through a hash function. Remember, it's a key value pair. So by default, the behavior is hash the key, mod the number of partitions, and then that tells us what partition to write to. And so that same key will always be produced to the same partition. What that tells us is all of the messages of a given key will always be in order. Messages with different keys, we have no ordering guarantee. Once you have more than one partition, you are giving up on global order. So picking your key tends to matter a lot, right? You pick the key really based on the ordering semantics you want to define. At least that's a thing that often drives your selection of key when you're modeling data in Kafka. All right, so partitioning. This lets us scale. I can now distribute a topic across many machines, many nodes, so I can scale writes, I can scale storage. If I want to remember data forever, I might want lots and lots of nodes with lots of disk space on them to be able to spread all of this stuff around. And I can also scale consumption. We'll talk about that in a minute. Ordering is inside a single partition only. That's my ordering guarantee, not between partitions. There's just no such thing. And this means that key selection matters a lot. Sometimes, and this is kind of interesting, sometimes say you might want things ordered by customer, I don't know, so the key is customer, so all the interactions of a single customer are in order. Maybe like if you're a retailer, you might want to see that same data but in order by store. Sometimes you want to see it by customer, sometimes you want to see it by store. Well, fun fact, since events are immutable, what you often do is you just make a copy of the topic. You write the same events to both topics and key them differently, and it's okay. It's immutable. It's not like you're going to change one and the other topic will be out of date. That's impossible because they're immutable. You get to get away with data modeling murder, but like a good kind. So anyway, what next? Replication. This is important. It's kind of like a little aside, but you wouldn't take Kafka super seriously as a as a piece of distributed data infrastructure if it didn't do some kind of replication. And here's how that works. So here I've got 4 brokers. Let's call the nodes in a Kafka cluster. You call them brokers. And I've got a single topic with 4 partitions. So if we didn't replicate it at all, it would look like that. Those log files would be stored on those brokers. If I lost a broker, I'd lose the data forever, and that would be a bummer. So what Kafka does is it makes copies of the logs. And in all cases, one of those brokers is the leader and the other 2 are the followers. So when you talk about producing or writing to a partition, what you're really doing is you're writing to the leader. And when you're reading, at least as of the current version of Kafka, you're reading from the leader. There's a KIP, and that's a Kafka improvement proposal that's out in the world that is that may give you the ability to read from followers as well under some circumstances. But currently, right now, reading and writing always happen at the leader, which is a nice simplifying assumption. That does create all kinds of interesting questions about consistency and what qualifies as a successful write and all that kind of stuff. We won't get into that since this is a survey of the whole thing. But those questions, I will say, tend to be a little bit easier to reason about in Kafka because of the leader-follower thing. You just have one place where the writes go. And that eliminates half of your consistency woes. So yeah, anyway, if one of those brokers goes away, then we just elect a new leader that is from the group of followers that is all caught up. You know, one of the functional lead working followers gets elected as leader. So that's partitioning. Okay, let's get out of the Kafka cluster and start talking about application code. So everything I've talked about so far is what happens in a Kafka cluster. It's infrastructure. Now we need to think about how we use it, and that gets us into the world of the producer. The producer is a client program. It is software you write using a Kafka client library, and That client library is the kind of the native language, or the default library for Kafka is Java. Kafka is written internally in Java and Scala, and Java is the library that comes bundled with it. That producer really just writes to a partition is what it does. It handles all the plumbing. There's a connection pool, there's the whole hashing of the key, waiting for an acknowledgement and retransmitting if it didn't get, all that kind of stuff that you in a million years don't want to do if you're trying to get paid for writing application software. That all is done inside the producer. That is example producer Java code, pretty simple stuff. You make a key value pair and you send it to the producer. There's a bunch of configuration stuff that I'm not showing, configuration parameters that go into a little map that you send into the Kafka producer constructor, but that's it, pretty simple. Not much to say about producers. Client applications though, remember this is code that you have written and it runs on a machine or a container or whatever outside of the cluster. It doesn't run on a broker. It's independent of the Kafka cluster itself and handles all that plumbing. I said Java was the default language. There are any number of community libraries, community maintained libraries. Go.NET, languages as .NET platform I should say, C, C++, Python, those are all Confluent maintained libraries, so they can be supported and all that kind of stuff. Broadly speaking though, you've got the Java libraries and other languages of the JVM tend to build around the Java library. And then there's this other open source project called librd Kafka. People usually say it quickly. They say Liberty Kafka. And I'm an American, I get this idea of a guy like playing a flute, and there's a guy with a drum and a funny hat and flag, patriotic. But it in fact is not the word liberty, it is librd Kafka. That's a C library. So JVM languages use the Java library. Everything else in the world pretty much is built around librd Kafka. There are a few other native implementations of the wire protocol in the world, but it's pretty much those two things. So here, for example, Go.NET, C, and Python, those are all librd Kafka. If you get like the closure library, that's going to just be built on the Java library. All right, consuming. Consuming is harder in Kafka. It might be better to give than to receive, but in Kafka it's harder to read than to write. So let's think about this. I've got 3 partitions in my little fake topic here, and if I have one consumer, that consumer, just one instance of that one consumer application is going to read from all 3 topics. Okay? Consumer is one thread, and so messages from those topics are going to arrive at that consumer. And from within a given partition, remember we know that they will always be in order. Between partitions we don't have a guarantee of what order they will arrive. So that one application is consuming all of them. Because Kafka is not a what? It's not a queue. When I consume a message, it doesn't really go anywhere. It's still there in the log. I've just read a message from an offset. Profound implication. That means I can have a second application consuming from that same topic, and I can keep going until I get tired of writing new code. There can be any number of consumers consuming from that one topic, which is kind of cool. If I've got data in there that's like, I don't know, orders that I shipped or something like that, or orders that were placed, who might want to do computation over such data? Well, people who ship orders. So somebody's writing a shipping service might care. Somebody who's writing a customer loyalty program service or suite of services might want to consume from that data. Somebody who's writing fraud detection might want to consume from that data. You don't even need to know who is writing that code. That data is there. Any number of consumers can now spin up and consume it, and that has far-reaching architectural implications for the kind of systems that get built on Kafka. So very big deal that you can have multiple consumers. That's consumer code. Let's not dwell on it. The point is that there are not very many lines of it. But I want to talk about scaling consumers. This matters. So right here I show one instance of consumer A and consumer B. Consumer A and consumer B are separate applications, right? Separate services. Let's say you don't do the mono repo thing. Those are separate repos and builds and everything. Maybe they're in different languages. I don't know, but they're different programs. What if I add features to consumer A that cause its computation to be more expensive? Right? It just needs to do more with each message. Well, I can now add another instance of that. And there's nothing I have to do to make this possible. I just add a second instance. It connects to the cluster. The cluster says, oh, you're the same group ID as this other thing. You're a group, and I'm going to start apportioning partitions fairly between the two of you. And I can keep playing that game until I have the same number of instances as I have partitions. Then you still scale out farther than that, but you won't be scaling reads anymore. So that is, I said before that partitions let us scale consumption. This is how. So once if the volume of messages goes up or the computational expense of processing a message goes up, I can scale that group just like that. So consumer, what's a consumer? It's a client application. It reads messages from topics, and I just explained that I didn't use these words, but I said that it is horizontally and elastically scalable. I can add consumer nodes at runtime, I can take them away, and the cluster automatically moves partitions between the consumers in the group, which is super cool. You know what the cluster doesn't do? So if I'm doing some kind of stateless computation, that's great, but probably I'm going to have some kind of state. I'll be doing something where I remember my last message. Let's say I'm computing an average. It's pretty darn stateful. Well, this mechanism doesn't help, so we're going to need more framework here than we have. If you have a stateful consumer, and you almost certainly do, then this library, the consumer library, will not help you scale that state. And you see this pattern over and over again, where these things happen in the ecosystem. Here's Kafka, it's got this set of functionality, people do some stuff with it, they realize, scaling state is a massive pain in the butt with consumer groups. What should we do? And other things arise. The community builds other parts of platform for you to solve those problems. And I'll show you what that is. All the same languages as producers. They're always the same library. All right, this is cool. So I could send you away with this and say, go build systems. And I said something, microservices. And you were like, that sounds good. And there are other talks online about how to do that. And you thought, yeah, let's go do it. And you would be doing well. But kind of really just doing assembly language Kafka. That's put message in, get message out. And like I said, there are problems that everybody runs into that you're going to run into if that's all you have. So we're going to need to do some more. For example, you're going to have some legacy system. And by legacy, I mean not Kafka. But there's going to be a database somewhere there's some other application. Somebody pointed out the slide is black. This slide is intentionally left blank. So this is a correct state of the presentation. Thank you, though, because it does look broken. It's just not. I just want you to pay attention to me. So there's a database somewhere, and there's some application that's using that database, and it's good, and there's no reason not to like it, but it's not data in Kafka, and you want that data in Kafka, right? You're going to say, I know how to do this. I'll just write like a little thing to run a query every second against that database, and if I see a new ID, I'll produce it to this topic. And it's done, right? That's so easy. You do that in an afternoon. You like consume new records from this database and put them in a topic. And then a month later, you can be, here's this other database. I need to do that same thing, but there's also like an updated at field there, and I need inserts and updates, so I'll change my code a little bit. Now I can see new records and modified records, and I'll do that. And like next week later, you're gonna be, hey, I've just copied and pasted this code. Let me write a framework. It's fun. Frameworks are great. You know what's great about frameworks is there is no product owner, there is no business analyst, there's no external stakeholder to make your code ugly. You are in charge, and you can write beautiful code, which you can't do when people in the real world outside of computer science are telling you what to do, right? So it's fun. Let's extract a framework. Well, my friend Admiral Akbar, one of the greatest software architects who ever lived, would remind us that this is a trap. And it's a trap because frameworks are not our job, right? They are fun, they are tempting, they are beautiful, and you can make them beautiful at least. But the problem is you really can't, because then you get caught doing it, and then you don't ever get to invest as much in the framework as you want. So it's a good idea, and this Kafka integration thing that you will write, given the opportunity, will always be partial and buggy. You're never able to put as much time into it as you want, because your job is to build features that deliver value to customers or whatever. So the framework thing is a trap. So this is really, we're talking about Kafka Connect here. That's what I just described. So in this kind of system, where Kafka forms a central nervous system, and there are these other kinds of things integrated with it. I gave an example of a database, but dumping stuff into S3 would be a thing, or integrating with, I don't know, Cassandra, whatever you might want to do. It's not this architecture. This architecture is fine. It's the arrows. The arrows are a bummer. And that's what Kafka Connect is. Kafka Connect is a declarative way of making those arrows happen without you writing that boilerplate low value code. I shouldn't say low value, it's very valuable. It's low differentiation. There's nothing, your business is not different because you figured out how to write stuff into S3, right? So Connect is infrastructure on the one hand. It's a server process that you run on a machine external to the cluster. So Connect is a client application. As far as Kafka is concerned, Connect is just a producer and a consumer. As far as you're concerned, it's this place to configure connectors. And a connector, let me show you an example of a connector. What's a connector look like? A connector gets configured with a little blob of JSON that you post to an endpoint on one of your Connect servers. And your Connect servers, by the way, can operate as a cluster. I can scale this out. So if I got a lot of Connect work to do, high volume, consuming or producing, I can run many Connect servers and have them all cooperating in that work. But I say, here's a little bit of JSON to configure the JDBC connector. And the JDBC connector is a jar that's available there on the Connect server. Connect wakes up and says, oh, okay, well, I'm doing this Connect work now. That job is off and running, and it's going to stay there. It's going to keep reading from that database, producing that topic forever. I'm giving the JDBC example because it's very easy to understand. Of course, the world is full of things to integrate with. And there's a website called hub.confluent.io, which is Confluent's repository of connectors of various licenses. Many of them open source. Some of them are third-party proprietary connectors. There's lots of things on there to connect to all the things in the world. And we're actually busy. This is a thing between you and me. It's being recorded. A thing that terrifies me, Internet. It terrifies me. We are working on writing a lot of connectors this year, and whose team is going to have to build demos for that? That's my team, Internet, and I'm worried. But we'll get it done for you. Okay, and you. It is, there's a lot of connectors, and there's going to be a lot more connectors because there's a lot of stuff to integrate with. And you don't want to write that code, right? It's fun, but it's not differentiated. It does not move your business forward. Okay. Let us move forward and talk a little teeny bit about schemas. This is another thing that you're eventually going to write. And when you look at early adopters, Yelp always comes to mind. They were a really early and sophisticated Kafka adopter. And all of these components of the ecosystem that exist as standard things now, that are open source or free or somewhere on that spectrum, they built before they existed. And so there are people, kind of the old school users who were there in the beginning, who have built their own. But this is another one of those things. You're going to have to keep track of the schema of things. You've got these key value pairs you're producing into topics. And I said before, oh, don't worry about them. Kafka doesn't care what the type is. Well, darn it, you care, right? That value is a serialized object of some kind. You're going to take some object in your language, whatever that language is, and you're going to serialize it in some serialization format that makes you happy. And sometimes a fun thing to do is to get on a website like Reddit or Hacker News or something and argue about serialization formats. Or maybe at a reception at a conference, have a few drinks and argue about Avro and Protobuf and just kind of see how it goes. The point is, this is a decision you make, and that value is an object that you serialize. And the schema of that object will change over time. We know this. Schemas always change, and that's often a little bit of a pain that they do, right? But I kind of suggested before, if you've got, I said, I gave that example when we were talking about consumers of a topic of validated orders or orders that were placed or something like that. And I just started kind of rattling off, what are some services that might want to consume those orders? And I just made some stuff up off the top of my head. You could probably continue to play that game and make up other kind of consumption interests on a given topic. And the fact that there can be these emerging services that can consume this immutable log of events that is stored in Kafka, stored durably in Kafka, is incredibly powerful, right? This is not what this talk is about, but just as an aside, that is a key to an evolutionary architecture. There are other ways to make that happen, but I think that this is a big one. And if you do that, and you should do that between you and me, but if you do that, then the schema of what's in the topics matters a lot. All of those services there that are reading, they need to know what's in there. What version of the object is there? And those services don't all get revved at the same time. They have their own independent histories and release cycles. Otherwise, it's not microservices. It's just an extremely inconveniently deployed monolith. So we have to know what's in those things. The Schema Registry is the answer to that. So the Schema Registry is another independent service. It's this service sitting out somewhere outside the cluster, and the producer and the consumer are configured to talk to it. So when we're writing a new message in, there's a bunch of magic that goes on that I won't talk about right now, that actually the experience as a developer of that magic is very lightweight. You see very little of it, but a bunch of cool stuff. When you go to produce a message, the producer reaches out to the Schema Registry, says, hey, have you ever seen this schema before? No? Okay, here it is. And then that gets a schema ID that gets cached locally. Then on the read side, the consumer will read a message and say, oh, schema number 5. I haven't seen that before. Schema Registry, could you tell me about that? Okay, I'll cache that locally. And the producer and the consumer are able to make decisions about whether those versions of the schema are compatible with their code. So you have a way of making sure when you're independently versioning producer and many producers and many consumers that you don't break anything. Obviously, there's still lots of opportunities to break things, but this is a tool that will eliminate some causes of schema evolution breakage. Super convenient tool. And that database thing, obviously not really a database, it's a topic in Kafka. If I wanted to store data, why would I store it anywhere else other than Kafka? Obviously. You just give a little bit of configuration on your producer or your consumer to get that kicked off. You define schemas. Schema Registry uses Avro right now, and so you use Avro's IDL, which is called AVSC, and it's a JSON format. It's yet another interface description language, but really not bad, and that gives us the ability now to define the schemas of our objects through this one file, which is now source controlled, and there's now a locus of I'll call this a locus of collaboration. This is where I go to negotiate schema change. There are build tools that'll generate Java wrappers and so forth for these schemas. That can all be automated in a fairly nice way. Now, moving on. Connect and Schema Registry are helper tools that you would build. And it's nice that they have been built for you. But Streams is yet another level up. If we recall this, these guys, the consumers, sometimes I get to visit customers, which is fun because I'll go in the room and usually meet with software architects, and you just don't know what's going to happen, right? You don't know what the problems of the business are going to be or what they're trying to do, and it's like battle architecture, right? They describe the problem, and you're like, wow, can I solve this with the tools that I have? Maybe. Usually it works out okay. But you ask a group like that of enterprise architects, and the good kind that write code, what do your consumers do? You have teams using Kafka. What do you do? And it's like not many different things. Some people say, well, we compute an aggregate. We compute an average or a max or a min or something like that. Okay, cool. We take streams and we turn them into lookup tables. And then we like enrich streams. Here's an event, and I got to go look up something based on some key and produce a new event. Or maybe some funky stuff is joining one stream with another. That's really weird. Actually hard to think about. Plus, this is all going to be container friendly and scalable and all that stuff. This is it, right? This is what people do in their consumers. And to do this with just the consumer API, again, Admiral, you should think of the little Admiral Akbar sitting on your shoulder saying it's a trap. There's a lot of framework code that you're going to write here if you're not careful, because the consumer API doesn't do any of this stuff. But Kafka Streams does. Kafka Streams is a Java API. So if you're a Java shop, that's great news. If you're an anything but Java shop, that's less great news. But it's a Java API. It has opinions about the world, and that's how it is. It's a functional API. So if you've worked with, and this is a lot less rare than it used to be, but any kind of functional collections framework or a properly functional language, this looks very familiar. You describe things with Java lambdas, like say you have a topic and you want to filter it, or that's a stream and you want to make a new stream that's a filtered version of the previous stream. You'll provide a lambda that describes the filtering logic. And so that lambda now can be fairly simply tested, and it's a nice paradigm. I don't think I need to sell you on functional programming. It's all the framework you'd build to do all that stuff, to manage state. Oh boy, the state management stuff is huge in here. It has abstractions for streams and tables. I can take a topic and turn it into a lookup table. I can take a topic and compute an aggregate over it. And if I aggregate an event stream, that implies that I am grouping by something, whether the key or some field in the message itself. And once I have grouped a stream, in essence, I have what is now a table. And so Kafka Streams provides an abstraction for that. There's so much to say about that, well, Kafka Streams really is its own 45-minute introduction. This is the super lightweight thing, but lots of good stuff to read online, good tutorial videos online that you can find about this that explain that stream table duality in some detail. State is huge here. Since I can make tables, tables are stateful, and I need to be able to scale this across many instances of the application, just like I can with a consumer group. So what Kafka Streams does is that problem of scaling state of when, say, a node in my 5 nodes of my Streams app, when one of those goes away, it had state in memory for the chunk of the table, the partitions that it was managing. I need to go get that state from somewhere, and it lets us do that. I'll let you in on a little secret, like what's the distributed fault-tolerant state store that Kafka Streams uses to persist state? You're right, it's Kafka. So yeah, it uses internal topics to manage all that. So these things, these consumers, are not just this vanilla, give me a message, let me process this message code. These are now Streams applications. And this code, this is actually a complete streaming application, all in one public static main void, or public static void main method. And this takes one topic and turns it into a lookup table, takes another topic, groups it, aggregates it, then joins the two and emits the joined table that results to a new topic. And that looks like a lot of code, and like I said, that's like 20 minutes to walk through all that or live code it, so that's a fair investment right there of kind of presentation time. But you get an idea that that's what it looks like. That's how you do that. So streams, absolutely essential. If you're writing microservices in Java, you're going to use streams. If you're writing services in some other language, we'll talk. But it gives us ways to filter, join, aggregate, all the stuff that you would do, but you don't have to write the framework for it now. Very, very important. Streams has this big architectural opinion, which is that stream processing lives in the application. Stream processing doesn't live in a special cluster over there. Like I don't have my Kafka cluster and then my streaming cluster, and I write a special streaming program against a Java or Python or whatever API and put it on this cluster and it runs there. Stream processing is a thing my application does. That's how Kafka Streams does it. And that's important. So if you've got some service that has some interface, it's say a Spring Boot app and it's got some web interface or some REST interface or something that you want it to do, but it also does stream processing, all that code lives in one place. And so you can fit that whole thing into your head and you can deploy it in whatever way you want. It's a Java application. You build a WAR file and drop it into a Tomcat 4 hot deploy directory that we can still be friends. It happens, right? Not everybody is off of that. Do you have a build process that runs the master branch through CI, and if it tests pass, it packages it up and throws it into Kubernetes? It doesn't matter how sophisticated you are. Kafka Streams doesn't care. It's sort of deployment neutral. And the last part of the platform for today. What if you don't want to write in Java? Or what if I talked about how stream processing in Kafka Streams is located with the application, but what if you have stream processing that doesn't have an application to go with it, right? It's really just, I've got this stream and I want to do some analysis and make a new topic with results in it and there's nothing else to do. I just need to make the topic, right? Well, that's where KSQL comes in. KSQL, it looks like this, okay? And that you can kind of scan through that and there's not too much that's upsetting about it. That really looks all like SQL, honestly. It has the same stream and table dual concept, so I can take a stream and make it into a table. I can take a table and the table automatically gets persisted to a new topic. So streams and tables, in the opinion of KSQL, are kind of two sides of the same coin. And because this is for stream processing that doesn't have an application glued to it, it does still need a place to run, and that's a KSQL cluster. So I start up a KSQL server node, and I can scale that out and up, out and back elastically, just like a consumer group, just like a Kafka Streams application. In fact, a lot like a Kafka Streams application, because KSQL happens to be a Kafka Streams application. But that's an implementation detail you don't need to care about. You can deploy a KSQL cluster. It will consume from Kafka topics, do its thing, and then produce results back to a Kafka topic, which can then be consumed or connected or done with whatever you would like. So this is the platform's declarative stream processing language, and does all those same things that Streams does, runs on its own cluster. So we've built up, this is supposed to be blank, by the way. We built up a whole platform. Started with a key value pair. We talked about organizing them into topics, partitioning them, replicating them, how to get stuff in, how to get stuff out, emergent needs like Connect, data integration, schema management, and sophisticated stream processing in either Kafka Streams or KSQL. That's all stuff that you could have done with just the producer and consumer API. I mean, fundamentally, those things are things that are just done with the producer and the consumer API. But those are all there. So where this gets us is back to where we started, which is you are a person who writes programs. And I think what modern Kafka encourages you to do, Kafka 6 years ago, 8 years ago, when it was brand new, was really like, hey, I need to get some stuff into Hadoop real fast. How do I do that? That's not, like most of us didn't care. That just was not very broadly applicable. But if you're just a person who writes programs and those programs process events, modern Kafka encourages you to think of your events as things that come first. Model events first, build your software around logs of immutable events. And then that lets you write your program, not build a bunch of framework, because that framework has, for the most part, sort of emerged around Kafka. You get to write the code you're writing and let Kafka do what it does well. So, thanks.